Good morning, everybody. Can you hear me?
Yes, sir. Good morning, sir.
Yes, sir. Good morning.
Yes. Can all of you hear me?
Yes, sir.
Yes, sir.
Okay. So we are going to continue with the same topic as we were discussing last time. We were talking about the evaluation of state transition matrix. Do you remember what we were doing last time? Basically, we are learning how to numerically evaluate this matrix, state transition matrix. And why do we want to numerically evaluate it? Because we know that the solution of the state equation is given by homogeneous state equation is given by xt equal to e to the power at x naught. And for a non-homogeneous state equation, we have seen this is for homogeneous state equation. Solution of homogeneous state equation. For the non-homogeneous state equation है उसका हमने solution देखा था. It has two parts. xt equal to e to the power at x naught plus integral of 0 to t e to the power a t minus tau b u tau and v tau. Isn't it? This is the solution of this we have already proved non-homogeneous state equation. Now, given the initial conditions and given the input, if you are asked to evaluate this, if you are asked to solve this equation and obtain the value of xt, you need to know how to evaluate e to the power at. यहाँ पे भी चाहिए होगा आपको और यहाँ पे भी आपको e to the power at चाहिए होगा how to evaluate it. So basically, our topic is which we have started this topic last time. That is how to evaluate the state transition matrix, and one method I have already shown you. What was that method that we did last time for evaluation of state transition matrix?
ट्रांसपोज निकाल के फिर सॉल्व करना होता था सर.
Using Laplace transform method, है ना?
यस.
This we have already done. This method we have seen that e to the power at can be evaluated as what? We can obtain e to the power at as Laplace inverse of Si minus A inverse into x naught. No, Laplace inverse of Si minus A inverse, isn't it? Is that okay?
यस सर.
ये हमने प्रूव किया था लास्ट टाइम. तो इसमें Si minus A inverse जो है मैथमेटिकल कॉम्प्लेक्सिटी इसमें इन्वॉल्व है Si minus A inverse इवैल्यूएट करने में. So this may be suitable for if you are doing it on paper. So this method may be suitable for matrices of the order of let's say 3, at the most 3. अगर A का order 4 हो तो उसका फिर inverse obtain करना becomes quite complicated, isn't it? But nevertheless, this is one of the methods that's used for evaluation of state transition matrix. And by the way, let me tell you that this Si minus A inverse, this matrix is known as the resolvent of A. In matrix literature, this matrix Si minus A inverse is known as a resolvent of A. This is just for your information. तो ये वाला मेथड तो हमने ऑलरेडी किया हुआ है. आज मैं आपको और एक मेथड दिखाऊंगा स्टेट ट्रांजिशन मैट्रिक्स को इवैल्यूएट करने का. So is the context of the lecture clear to you? So we talk about method number 2. Method number 2 is using Caley-Hamilton method. Caley-Hamilton theorem. Have you learned this theorem in your matrices course? Yes. ये थ्योरम पढ़ी है आपने? आई एम वेटिंग फॉर योर रिस्पॉन्सेज।
सर पढ़ी थी मगर भूल गए।
पढ़ी थी? हाँ,
बिल्कुल सर, पढ़ी थी सर।
पढ़ी थी नहीं, पढ़ी है आपने? व्हाट डज दिस थ्योरम स्टेट? The statement of this theorem is every square matrix
satisfies its characteristic equation.
satisfies its own characteristic polynomial, isn't it? The equation satisfies its own characteristic equation. दिमाग पे जोर डालो तो याद आ जाता है. But the point is that you have to lay some things, थोड़ा सा mind को activate करना है. Every square matrix satisfies its own characteristic equation. What's that? What does that mean actually? So if A is a square matrix of order n, then its characteristic polynomial or characteristic equation is defined as delta lambda is equal to, it's a polynomial actually, lambda n plus alpha 1 lambda raised to n minus 1 plus alpha 2 lambda raised to n minus 2 plus so on, alpha n minus 1 lambda plus alpha n equal to 0. Isn't it? For a square matrix of order n, the characteristic equation is defined like this. Then as per Caley-Hamilton theorem, this is actually equal to determinant of lambda I minus a, isn't it? As per Caley-Hamilton theorem, if we evaluate delta, and for this lambda, if we substitute A, this matrix A, that means this equation will become a matrix equation.
लैम्डा की जगह ए आ जाएगा.
Lambda की जगह A आ जाएगा. This is a to the power n plus alpha 1 a to the power n minus 1 plus alpha 2 a to the power n minus 2 plus so on. Alpha n minus 1 a plus what? Alpha n into I is equal to a big zero, a matrix zero, a null matrix. Isn't it? Proof इसका trivial है. अगर आप यहाँ पे determinant of lambda I minus a की मैं lambda की जगह a डाल दो, so this becomes determinant of lambda a I minus a. Isn't it? That becomes determinant of zero matrix. That is actually zero. Do you get me?
Yes sir.
Okay. So this is what this theorem states. Where I is the identity matrix and this big zero is a null matrix. You get me? So this theorem basically will be using to evaluate state transition matrix. Let's see how. Let's see how we can use it to evaluate state transition matrix. And in fact, not only state transition matrix, any matrix function of a square matrix can be evaluated by use of Caley-Hamilton theorem. I'll show you how we can do that. So consider matrix polynomial function FA. FA is a polynomial function defined as FA is equal to alpha naught plus alpha 1A. It should be actually alpha naught I plus alpha 1A plus alpha 2A square plus so on alpha n a to the power n plus alpha n plus 1 a to the power n plus 1 plus so on. We are considering a matrix polynomial function FA, which is defined like this. You already know that your e to the power at is also of the same format. E to the power a या e to the power at का format भी similar है. तो हम एक general matrix function polynomial function FA के लिए देखेंगे कि कैसे हम Caley-Hamilton theorem से उसको evaluate कर सकते हैं. The dimension of A is the size of order of A is n. The order of A is n, and the degree of this matrix polynomial function FA is greater than n. A का साइज A का ऑर्डर n है और ये जो मैट्रिक्स पॉलिनोमियल फंक्शन है इसका डिग्री जो है वो n से ज्यादा है, तभी मैंने ये वाली टर्म यहाँ पे लिखी e to the power n plus 1 वाली. Is that clear? I am considering a matrix polynomial function FA which is defined like this. The order of A is actually n. A is a square matrix. A is a square matrix. Which is obvious actually, because this A square, A to the power n, you can compute this for square matrices only. The order of A is n and the degree of this matrix polynomial function FA is greater than n. As you can see here, it's greater than n. The corresponding scalar polynomial can be defined as scalar polynomial function. The corresponding scalar polynomial function can be defined as, basically I need to evaluate this matrix function, and I can do that by defining the corresponding scalar polynomial function as f lambda. That means substituting lambda for A. So that I can define as alpha naught plus alpha 1 lambda plus alpha 2 lambda square plus so on alpha n lambda raised to n plus alpha n plus 1 lambda raised to n plus 1 plus so on. This is a scalar polynomial function defined correspondingly for this matrix function. Matrix function is a function of A, and is defining a corresponding scalar polynomial function by substituting lambda for A, while lambda is any variable, a scalar variable. Is that okay?
Yes, sir.
Is that clear? Okay. Now I will do some mathematical operations like this. If I do like this, if I divide this f lambda by delta lambda, where delta lambda is the characteristic polynomial of matrix A. I am dividing this f lambda by delta lambda, where delta lambda is the characteristic polynomial of this matrix A. So this polynomial, which is of degree greater than n, I am dividing it by a polynomial delta lambda whose degree is, delta lambda की degree क्या है? What's the degree of delta lambda? Which is a characteristic polynomial of A. Yes. Waiting for your response.
n, degree n.
डिग्री n. तो आप एक डिग्री एक पॉलिनोमियल का जिसका डिग्री n से ज्यादा है उसको आप दूसरे पॉलिनोमियल से डिवाइड कर रहे हो जिसकी डिग्री n है. So you will, when you will do this polynomial division, you can express it like this. You will get some quotient polynomial which I call as q lambda, plus you will get some remainder polynomial which I name as r lambda divided by delta lambda. जब आप दो पॉलिनोमियल्स को डिवाइड करते हो, जैसे मान लो ये मेरे पास एक पॉलिनोमियल है s to the power 4 plus s cube plus s square plus 3s plus 3. I divide it by some polynomial which is having degree less than this. Let's say s square plus 2s plus 1. Is that okay? So I carry out the division. I do like this s square. So this becomes s4 plus 2s cube plus s square. This is minus, and this is minus, this and this goes. So I get minus s cube, and this also goes, plus 3s plus 3. Isn't it? I can do the multiplication once again. So plus s, what do I get here? Or minus s. I get minus s cube, then minus 2s square. So yeah, and then minus s. So this and this goes. So this is plus, this is plus. So I get 4s plus 2s square plus 3. So I get something like 4s plus 2s square plus 3. Now I multiply it once again by 4. So this is by 2. So I get 2s square, then plus 4s. Then I will get plus 2. Have I done it correctly? This is minus, this and this goes, this and this goes. So I get 1 here. So this is the remainder polynomial, and this is the quotient polynomial. Now you already know that this we call as the dividend, this we call as the divisor polynomial. This dividend polynomial can always be expressed as, what is dividend equal to? It's equal to divisor into quotient plus remainder. Isn't it? Are you getting me? I'm just talking about basic arithmetics.
Yes, sir.
So if I divide these both sides by this divisor, so I will get dividend upon divisor is equal to coefficient plus remainder upon divisor. Is that okay? That's what I have written here. वही चीज लिखी मैंने यहाँ पे. I'm dividing two polynomials, f lambda by delta lambda. I get a coefficient polynomial plus remainder divided by divisor polynomial. Is that okay? और ये डिवीजन रुकेगा कहाँ पे? ये डिवीजन रोका क्यों हमने यहाँ पे? जब रिमाइंडर पॉलिनोमियल की डिग्री डिवाइजर पॉलिनोमियल से कम हो जाएगी, you cannot perform division after that, isn't it? Is that okay? तो मैं दो पॉलिनोमियल्स को आपस में डिवाइड कर रहा हूँ. f लैम्डा को मैंने डेल्टा लैम्डा से डिवाइड किया. f लैम्डा का डिग्री n से ज्यादा है, इट्स ग्रेटर देन n. I am dividing it by a polynomial of degree n. So I get a quotient polynomial, and then I get remainder polynomial. And what will be the degree of the remainder polynomial? At the most, इसकी डिग्री क्या होगी? Remainder polynomial का डिग्री क्या होगा?
So less than n.
Less than n means
N minus 1.
at the most it will be
minimum.
n minus 1. But r lambda is a polynomial having degree at the most equal to n minus 1. Is that clear? It will be a polynomial having degree at the most equal to n minus 1, and it can be defined as can be defined as R lambda equal to beta naught plus beta 1 lambda plus beta 2 lambda square plus so on beta n minus 1 lambda is 1 n minus 1. Are you getting me? So this remainder polynomial can be defined like this because it is a polynomial having degree at the most equal to n minus 1. तो इसका general form यही होगा. Even if it is less than n minus 1, then those particular terms will not be there. Is that okay? Now coming back to this expression, I have f lambda upon delta lambda equal to q lambda plus r lambda delta lambda. I can write this expression like this. F lambda is equal to, so if I call this as equation 1, equation 1 can be written as f lambda equal to q lambda delta lambda plus r lambda. Is that okay? F lambda can be written as q lambda delta lambda plus r lambda. Are you following the steps?
Yes, sir.
Okay. Let us assume that the matrix A has distinct eigenvalues lambda 1, lambda 2, so on up to lambda n. तो मैट्रिक्स A है, हम assume कर रहे हैं कि इसके डिस्टिंक्ट, क्योंकि इसका ऑर्डर n है, हम assume कर रहे हैं कि इसके डिस्टिंक्ट आइगन वैल्यूज हैं at lambda 1, lambda 2 up to lambda n. So if we evaluate this equation 2, if we evaluate equation 2 at lambda 1, lambda 2, so on up to lambda n, what do we get? If we evaluate this f lambda, evaluate it like this, at lambda equal to lambda I will call it, where I runs from 1 to n, that will be equal to q lambda delta lambda evaluated at lambda equal to lambda I plus r lambda evaluated at lambda equal to lambda I, where I goes from 1 to 1 to n. Now please try to understand this. So this will be f of lambda I. This will be q lambda I delta lambda I plus r lambda. Lambda I is the eigenvalue. Delta lambda क्या है? What is delta lambda? Delta lambda is, yes, delta lambda is the characteristic polynomial. Characteristic polynomial. और अगर आप characteristic polynomial का आइगन वैल्यूज पे इवैल्यूएट करो तो इसका वैल्यू क्या आएगा? अगर आप characteristic polynomial में lambda की जगह आइगन वैल्यू डाल दो, so what will you get delta lambda I as?
0 sir.
Characteristic equation के solution को क्या बोलते हैं?
सर 0 आएगा.
It's 0 आएगा because this is actually the solution of this polynomial equation, isn't it? So delta lambda I is actually equal to 0 because lambda I is the eigenvalue and delta lambda is the characteristic polynomial. So when you evaluate the characteristic polynomial at the eigenvalue, so that will be equal to 0. So that this means f lambda I will be equal to what? R lambda I, isn't it? Which implies f lambda I equal to r lambda I. Is that okay? And what is r lambda hai kya actually? R lambda is this, isn't it? R lambda is your beta naught plus beta 1 lambda plus beta 2 lambda square plus so on up to beta n minus 1 lambda raised to n minus 1. So I can write this as or f lambda I is equal to beta naught plus beta 1 lambda I plus beta 2 lambda I square plus so on beta n minus 1 lambda I raised to n minus 1. The index I runs from 1 to n because these are the eigenvalues. So if I go on substituting the values of I equal to 1 to up to n, so how many equations I will get? On substituting I is equal to 1, 2, so on up to n, we will get n simultaneous equations. N simultaneous equations which can be solved to get the unknowns, which can be solved to get the unknowns beta 1, beta 2, so on up to beta n minus. तो बेसिकली अगर आपको कोई मैट्रिक्स पॉलिनोमियल इक्वेशन सॉल्व करनी है, मैट्रिक्स पॉलिनोमियल फंक्शन आपको इवैल्यूएट करनी है, तो प्रोसीजर क्या है? कैली-हैमिल्टन थ्योरम बोलता है कि आप कॉरेस्पॉन्डिंग स्केलर पॉलिनोमियल इक्वेशन लिखो, स्केलर पॉलिनोमियल डिफाइन करो, एंड देन दैट स्केलर पॉलिनोमियल दैट कैन बी इवैल्यूएटेड यूजिंग दिस एक्सप्रेशन व्हिच कैन बी जिसमें कि अननोन्स बीटा नॉट बीटा 1 अप टू बीटा n minus 1 है, वो अननोन्स इवैल्यूएट किए जा सकते हैं by evaluating this particular equation at the eigenvalues which vary from 1 to n. Once you substitute the eigenvalues, you get n simultaneous equations which can be solved. This is actually from beta naught to beta, because this is beta naught beta 1. These n simultaneous equations can be solved to get these n unknowns from beta naught to beta n minus 1, and then these unknowns can be used to find the corresponding matrix equation. वो हम कैसे कर सकते हैं? अभी तो मैंने f lambda I ऑब्टेन किया, जो मेरा एक्चुअल पर्पस था नहीं, इसमें मुझे बीटा नॉट बीटा 1 बीटा 2 मिल गया. So I will use these beta naught beta 2 beta 1 up so on in the corresponding matrix equation. ये जो मेरे पास इक्वेशन यहाँ पे थी, this one, I have equation like this: f lambda. I've got f lambda equal to q lambda delta lambda plus r lambda. इस इक्वेशन का corresponding matrix equation क्या होगा? The corresponding matrix equation of equation number 2 will be the corresponding matrix equation of equation 2 will be f of a is equal to qa delta a plus ra. That means lambda की जगह मैं वापस a डाल रहा हूँ. And as you know, as per Caley-Hamilton theorem, every square matrix satisfies its own characteristic polynomial. So what will be this delta a equal to? As per Caley-Hamilton theorem, जिसकी स्टेटमेंट मैंने स्टार्ट में दी थी, what will be delta a equal to? Delta a will be equal to what? This is the characteristic polynomial. This will be equal to 0. So this implies f a will be equal to r a. And r a is what? You know, r lambda is equal to beta naught plus beta 1 lambda plus 1 up to beta n minus 1 lambda is for n minus 1. So when we substitute a for lambda, what will I get? I'll get beta naught I plus beta 1 a plus beta 2 a square plus so on beta n minus 1 a to the power n minus. Actually मैंने evaluate ये करना था. ये इवैल्यूएट करने के लिए मैंने कॉरेस्पॉन्डिंग स्केलर फंक्शन ली और स्केलर फंक्शन को मैं एक्सप्रेस कर पा रहा हूं. मैंने प्रूव किया दैट द कॉरेस्पॉन्डिंग स्केलर फंक्शन f lambda that can be expressed in terms of r lambda, where r lambda has this format beta naught plus beta 1 lambda plus so on up to beta n minus 1 lambda raised to n minus 1. तो यहाँ पे ये स्केलर फंक्शन को मैं इवैल्यूएट कर सकता हूँ. इस इक्वेशन को जब मैं आइगन वैल्यूज इसमें डाल देता हूँ, आई गेट n simultaneous equations which I solve and I get beta naught beta 1 up to beta n minus 1. Those betas I substitute here with the given a, I'll be able to get fa. This is how we can solve the state transition matrix or any matrix function, because I have ये जो मैंने प्रोसीजर बताया है आपको यहाँ पे, ये किसी भी मैट्रिक्स फंक्शन को आप इवैल्यूएट कर सकते हो using Caley-Hamilton theorem by using this procedure. I'll try to illustrate this procedure by means of an example that will clear many things for you. But the procedure actually and the background behind it you should be clearly knowing. So the corresponding matrix function fa, which can be any matrix function, can be evaluated by using this expression, wherein the beta naught, beta 1, beta 2 up to beta n minus 1 have been already evaluated by solving those n simultaneously. Is that clear? Is that clear or not? Let me try to illustrate all this procedure with the help of an example. अभी तक जो हमने लिया, अभी तक हमने वो केस लिया जिसमें कि eigenvalues distinct हैं. I'll show you another case also wherein the eigenvalues are not distinct. So I'll take an example. Let's say you have to evaluate a to the power 20 for a is equal to 0, 1, minus 2, minus. आपको एक मैट्रिक्स फंक्शन a to the power 20 इवैल्यूएट करनी है एक स्क्वायर मैट्रिक्स के लिए जो कि जिसका कि ऑर्डर 2 है. We have to use Caley-Hamilton theorem for this. अगर आपको नॉर्मली ये करना हो कैसे करोगे? Yes. How do you solve this problem? See the procedure. Here, the matrix function that I have to evaluate, that is fa, that is equal to a to the power 20. Isn't it? So in order to evaluate this, we will consider the corresponding scalar polynomial. That is, we will substitute lambda for a. I'll consider the corresponding scalar polynomial. F lambda is equal to lambda raised to 20. Is that okay? We have already proved that f lambda can be expressed as f lambda equal to, कैसे कर सकते हैं इसको एक्सप्रेस? अभी जो हमने प्रूव किया, we can write f lambda that is equal to r lambda when evaluated at lambda equal to lambda I, where lambda I is the eigenvalue. So it can be written as beta naught plus beta 1 lambda plus beta 2 lambda square plus so on beta n minus 1 lambda raised to n minus 1 evaluated at lambda equal to lambda. तो मैं f lambda को कैसे एक्सप्रेस कर सकता हूँ? If I evaluate it at lambda equal to lambda I can express it as, yes, help me. I can express it as a polynomial of degree at the most n minus 1. What is n here? n क्या है यहाँ पे?
2, sir.
2. So what will be f lambda equal to? It will be beta naught plus beta 1. Yes, beta 1 lambda evaluating at lambda equal to lambda I. Lambda I is the eigenvalue. How many eigenvalues will this have? इसके कितने eigenvalues होंगे?
2 sir.
बताओ क्या क्या होंगे? Eigenvalues of matrix A. How do you evaluate that? Every determinant of lambda I minus A equal to 0. बताओ हमको evaluate करके क्या आ रहा है इसमें eigenvalues की वैल्यू? लैम्डा 1 बताओ कितना आ रहा है और लैम्डा 2 बताओ कितना आ रहा है? जल्दी से ये जो मैट्रिक्स ए है इसके हमें बताओ आइगन वैल्यूज क्या आएंगे जल्दी से बताओ इट शुड नॉट टेक दिस मच टाइम
Sir, -1 and -2.
-1 and -2 okay. So this is -1 and -2 now in this equation if I put first of all lambda equal to lambda 1 that's -1 so at lambda 1 or for lambda 1 equal to -1 so if I evaluate this expression so f lambda is for 20 so lambda 1 raised power 20 is equal to beta naught plus beta 1 into lambda 1 so lambda 1 is -1 so this is -1 raised power 20 is equal to beta naught plus beta 1 into -1 so this becomes 1 or I can write like this beta naught minus beta 1 is equal to 1. This becomes my equation number 1. Is that clear? Now again I will evaluate this expression for lambda 1 equal to -2. So for lambda 2 equal to -2, so what will I get here? This will be lambda 2 raised power 20 beta naught plus beta 1 into lambda 2 which implies -2 raised power 20 is equal to beta naught minus 2 beta 1. What is 2 to the power 20 equal to? Yes. What is 2 to the power 20 equal to? बताओ मैं वेट कर रहा हूँ. Take out your calculator and evaluate it. Like
1048576. 1048576.
This is what is 2 to the power 20 equal to. Is that okay? This becomes your equation number 2. Now this equation 1 and 2 can be solved simultaneously and from that we can get the value of beta naught and beta 1. Equation 1 and 2 can be solved simultaneously to get beta naught and beta 1. बताओ मुझे beta naught का वैल्यू कितना आ रहा है beta 1 का वैल्यू कितना आ रहा है इक्वेशन सॉल्व करनी आती है ना आपको we have got beta naught minus beta 1 equal to 1 and then you have got beta naught minus 2 beta 1 equal to 1048576. So this is minus, this is plus, and this is minus. So this goes. So beta 1 will be equal to minus 1048575. Is that okay? And beta naught will be beta naught आप इसको वापस इसमें सब्स्टिट्यूट करके ऑब्टेन कर सकते हो so that will be 1 plus this this is minus minus plus so this will be 1 minus this so that will be कितना होगा minus 1048574 Have I done it correctly? Is that okay? आप लोग सो गए क्या?
यस सर सही है
सही है. Okay, this is beta naught and beta. I thought you are saying yes sir सो गए हैं. So this is your beta naught and beta 1. We have evaluated beta naught and beta 1. लेकिन actually हमने evaluate क्या करना था? A to the power 20. Now FA can be evaluated as FA equal to A to the power 20 can be evaluated as FA equal to beta naught I plus beta 1A. So beta naught अभी हमने देखा कितना है? Beta naught is minus 1048574. I is 1001 plus beta 1. That's minus 10488575 into A. A is what? 0, 1, minus 2 and minus 2. So this is it. Minus 10488574. Then 0. Then 0. Minus 10488574. And this will be plus. This is 0. Minus 10488575.
2097150.
2097150. Yeah.
3145725.
725.
5.
Is that okay? Now we add them up. What do I get? I get minus 10488574 minus 10488575. Okay, this is 2097150. Okay.
2097151.
2097. This is your A to the power. अब बताओ मुझे कुछ पल्ले पड़ा कि नहीं? कैसे किया हम? Yes. Yes, I am waiting for your response. Would you understand it? How to evaluate this? Are you online?
यस सर
Yes, sir.
So could you understand how do you evaluate a matrix function using Caley-Hamilton theorem? कोई भी matrix function. यहाँ पे हमने e to the power 20 evaluate किया. तो हमारा जो actual problem था हमने e to the power 80 evaluate करना था. State transition matrix की evaluation हम देख रहे हैं actually. Isn't it? So, but this Caley-Hamilton theorem can be used in general for any matrix function. तो मान लो इसी प्रॉब्लम के लिए यहाँ पे मुझे a का वैल्यू दिया हुआ था 0, 1, minus 2 and minus 3. If I have to evaluate e to the power 80 using, that is state transition matrix, using Caley-Hamilton theorem. How will I do it? Tell me the steps. What is FA here? FA is the matrix function that we have to evaluate. So FA is e to the power 80. This is to be evaluated. Please see the steps, how we have to do it. What would be the corresponding scalar polynomial? The corresponding scalar polynomial will be f lambda equal to e to the power lambda t. Isn't it? That means we substitute lambda for a. And we have seen that it can be expressed in terms of a polynomial having degree at the most equal to n to the power n minus 1. That is beta naught plus beta 1 lambda raised power Yes, beta naught plus beta 1 lambda is for n minus 1. Here n is 2. So beta naught plus beta 1 lambda. Where when it is evaluated actually for at lambda equal to lambda 1 and lambda 2. This will also be evaluated at lambda 1, lambda 2. So if we evaluate it at lambda 1, so at lambda 1, we have already seen its eigenvalues are minus 1 and minus 2. At lambda 1, it is equal to minus 1. I will get the expression as e to the power lambda 1 t is equal to beta naught plus beta 1 lambda 1. Lambda 1 is minus 1. Or I can write e to the power minus t is equal to beta naught, lambda 1 is minus 1, beta naught minus beta 1. This becomes the equation number 1. And when I put lambda equal to lambda 2, that is at lambda equal to lambda 2, which is equal to minus 2, I will have e to the power lambda 1 की जगह minus 2 आ जाएगा, minus 2t is equal to beta naught plus beta 1 into minus 2. That is e to the power minus 2t is equal to beta naught minus 2 beta 1. This is equation 2. ये दो equations बनी है आपकी. दो equations को simultaneously आप solve करोगे and you will get beta naught and beta 1. Tell me what is beta naught and beta 1? Solve 1 and 2 simultaneously. बताओ मुझे बीटा नॉट कितना आ रहा है और बीटा 1 कितना आ रहा है, जल्दी से. इतना टाइम नहीं है, जल्दी से करो. Solve these two equations 1 and 2 simultaneously and get me the value of beta naught and beta 1.
So beta 1 is e to the power minus 2 minus e to the power minus 2.
क्या रहा बीटा नॉट?
E to the power minus 2
e to the power minus t
minus
minus
e to the power minus 2
e to the power
minus 2.
minus
Sir,
Sir,
it is
2 times
2 into e to the power
Minus
minus t minus e to the power minus 2t.
minus 2t.
okay ऐसे.
2. Yes, sir. Yes, sir.
Okay, what is beta 1?
Beta 1 e to the power minus t
Okay,
minus e to the power minus 2t.
e to the power minus 2t. Is
Yes,
that
sir.
okay? तो ये बीटा नॉट और बीटा 1 हमने इवैल्यूएट किया, लेकिन मैंने एक्चुअली क्या इवैल्यूएट करना था? मैंने स्टेट ट्रांजिशन मैट्रिक्स इवैल्यूएट करना था. So I will now take FA. So therefore FA, which is actually e to the power 80, that will be equal to beta naught I plus beta 1a. मतलब जो ये स्केलर पॉलिनोमियल इक्वेशन है, इसमें मैं वापस अब लैम्डा की जगह a डाल रहा हूँ. So this is equal to beta naught I plus beta 1a. So beta naught आपने अभी इवैल्यूएट किया, that is 2 e to the power minus t minus e to the power minus 2t. Is it वही आ रहा था ना?
Yes, sir. Yes, sir. Yes, sir.
So this thing, and I is 1 0 0 1, then plus beta 1 is e to the power minus t minus e to the power minus 2t, and a is 0 1 minus 2 and minus 3. Is that okay?
Yes, sir.
So this will be equal to 2 e to the power minus t minus e to the power minus 2t, then 0 0 2 e to the power minus t minus e to the power minus 2t, then plus this is 0 e to the power minus t minus e to the power minus 2t, then minus 2 e to the power minus t plus 2 e to the power minus 2t, and minus 3 e to the power minus t plus 3 e to the power minus 2t. सही है?
Yes, sir. सही.
Okay. So what will be the answer now? यहाँ पे 2 e to the power minus t minus e to the power minus 2t, यहाँ पे ये वाली टर्म आ जाएगी e to the power minus t minus e to the power minus 2t, यहाँ पे क्या आएगा, दिस विल बी minus 2 e to the power minus t plus 2 e to the power minus 2t, तो यहाँ पे it will be minus e to the power minus t plus 2 e to the power minus 2t. This is your e to the power. ये आपका स्टेट ट्रांजिशन मैट्रिक्स। Is that okay?
Yes, sir.
Could you follow the steps?
Yes, sir.
I guess, and you can see that it is easier than that Laplace transform method. क्योंकि Laplace transform method में जो main ये है complexity वो आ जाती है because of the inversion operation that we have to perform on the matrix. And you know that inversion operation is a quite complicated operation, particularly when the size of the matrix increases. तो यहाँ पे ये जो प्रोसीजर मैंने आपको बताया स्टेट ट्रांजिशन मैट्रिक्स को इवैल्यूएट करने का, इसमें हमें assumption एक ली थी कि मैट्रिक्स पे हमने A है उसके आइगन वैल्यूज डिस्टिंक्ट हैं. In case the आइगन वैल्यूज आर नॉट डिस्टिंक्ट, दैट मींस अगर मान लीजिए कुछ आइगन वैल्यूज रिपीटेड हैं, मान लो एक आइगन वैल्यू दो बार रिपीट हो रहा है, तो आपको तो इक्वेशन 3 चाहिए बीटा नॉट, बीटा 1 और बीटा 2 ऑब्टेन करने के लिए. लेकिन क्योंकि दो आइगन वैल्यूज रिपीट हो रहे हैं, जब आप बीटा नॉट मान लो बीटा नॉट और बीटा 1 सेम है, यू विल गेट ओनली टू इक्वेशंस. If you have a matrix A of order 3 and you have 3 eigenvalues, you will have 3 eigenvalues, and let's say 2 of them are repeated. So when you substitute this lambda 1 equal to those 2 eigenvalues, you get the same equation. But there will be 3 unknowns, beta naught, beta 1 and beta 2. How do you solve for those? How do you get 3 equations so that you get to solve them and obtain beta naught, beta 1 and beta 2 and finally substitute here? तो हम वाला केस कंसीडर करेंगे जिसमें कि आइगन वैल्यूज डिस्टिंक्ट नहीं है, और उसमें देखेंगे कि इसमें कैसे हमें हाउ डू वी एक्चुअली सॉल्व दिस सिस्टम. इज दैट क्लियर आपको? अभी तक क्लियर है?
Yes, sir.
Yes, sir.
Okay, so from now onwards, because I have some other engagement, I will hand it over to Danish. He will tell you about that particular case wherein the eigenvalues are non-distinct, and he will also solve one numerical on that. And then we'll require your feedback regarding this, whether you have completely understood it or not. Go to Danish.
Okay, we'll take an example. Example सबको ज़्यादा समझ में आएगा कि अगर if you have repeated eigenvalues, so एक extra equation कैसे जनरेट होगी. Write an example. Okay, this is the example. Consider a system x dot equal to ax. ठीक है, इसमें कोई forcing function नहीं है, it's a homogeneous system. Well, A is this. ठीक है, 3/3 system है, and you are also given initial condition. ठीक है, and you have to evaluate f of A equal to e to the power at, जो कि state transition matrix है. ठीक, जो अपने मेथड पढ़ा अभी using केली हैमिल्टन थ्योरम, तो उसी के थ्रू हम करेंगे। अच्छा, ये मैट्रिक्स जो आपका ए है, इसका एक स्पेशल स्ट्रक्चर है, अगर आप इसको केयरफुली देखो। व्हाट्स द स्पेशल अबाउट दिस ए? Any special thing you are noticing about this A matrix? This is in second companion form. आप ध्यान से देखो, ये जो मैट्रिक्स है इसके सब डायगोनल्स में 1 है और राइट कॉलम में you are having the coefficients. So this is in second companion form. आपने जो सेकंड कंपोनेंट फॉर्म पढ़ा है, जब आपने इसकी डेरिवेशन की थी, सो यू नेम द वेरिएबल्स फ्रॉम लेफ्ट टू राइट, है ना? अगर आप वेरिएबल्स को राइट टू लेफ्ट नेम करोगे तो यू गेट दिस काइंड ऑफ फॉर्म, है ना? आपने 1 1 यहाँ पे देखा होगा, यहाँ पे 1 1 यहाँ पर है, बट स्टिल इट्स इन सेकंड कंपोनेंट फॉर्म। इसकी क्या एडवांटेज है न्यूमेरिकल में हम देखेंगे, बट विल फोकस ऑन वी हैव टू इवैल्यूएट अबाउट 80 इक्वल टू द पावर 80, एंड second part is you have to evaluate x of t, the solution. The second part. First, state transition matrix. Once you find the state transition matrix for this A and this is the conditions, then you have to find the solution also. Okay. So we'll start the solving using Caley-Hamilton theorem. Okay. Caley-Hamilton थ्योरम से आप कोई भी मैट्रिक्स फंक्शन को एक्सपैंड कर सकते हैं। यहाँ पे अब एक स्पेशल मैट्रिक्स फंक्शन दी गई है e to the power 80. Otherwise you can expand any function of a, not necessarily exponential. You can expand any function of a using Caley-Hamilton theorem. यहाँ पे हम e to the power 80 में interested हैं। So this can be expressed as, जब ने भी देखा, this can be expressed as f of a equal to e to the power 80, which is given. That's equal to what? It's equal to the remainder polynomial जो आपने भी देखा of degree n minus 1. अब यहाँ पे जो है degree is 3, so यहाँ पे degree एक कम होगी. So beta naught I plus beta 1a plus beta 2a square, isn't it? यहाँ पे ऑर्डर 3 था, तो यहाँ पे स्क्वायर तक हमें स्टॉप करना है। सो ये आपकी इक्वेशन है यूजिंग Caley-Hamilton थ्योरम, where बीटा नॉट, बीटा 1 and beta 2 using coefficients हैं, they can be computed by considering the corresponding scalar equation, isn't it? What's the scalar equation? अभी आपने देखा ना for 2 by 2 सिस्टम, यहाँ पे 3 by 3 सिस्टम है, और यहाँ पे एक स्पेशल केस है, हम आगे देखेंगे क्या होगा। तो ये कोएफिशिएंट्स जो है आपकी बीटा नॉट, बीटा 1 and बीटा 2, how we have evaluated this in the previous example using the corresponding scalar equation, which is what? Scalar equation यहाँ पे लिखा f of lambda, है ना? अभी तक it was matrix equation, now it's a scalar polynomial equal to g of lambda. अच्छा, f of lambda evaluated at what? Evaluated at lambda equal to lambda I, isn't it? That is equal to g of lambda, again evaluated at lambda equal to lambda. What lambda i's are what? They are the eigenvalues of A. Okay, and this is equal to what? Beta naught plus beta 1 lambda plus beta 2 lambda square, evaluated at lambda equal to lambda. ये समझ में आया आपको?
यस सर।
हाँ, तो ये मैंने स्केलर इक्वेशन लिखी, दिस इज कॉरस्पॉन्डिंग टू द मैट्रिक्स इक्वेशन. Scalar equation में matrix equation is I, A and A square, and scalar में it's simply 1, lambda and lambda square. So you have to evaluate this beta naught, beta 1 and beta 2. ठीक है, 3 unknowns ढूंढने हैं, उसके लिए आपको 3 separate independent equations चाहिए, है ना? So first of all we'll do what? The characteristic equation जो है ना आपकी, which we represent sometimes like this. This is equal to what? Determinant of lambda I minus a. अच्छा, यहाँ पे मैं कह रहा था, this is in second companion form. So evaluating determinant of lambda I minus a or evaluating the characteristic equation is very simple for this. Either आप step by step को expand करो, lambda I minus a, or you can straight away write. This is यहाँ पे एक जो है और lambda I minus a, lambda minus 1, lambda minus 3, 0, 2, 0, 0, minus 1, 0. This is your determinant of lambda I minus a. And this has to be equal to 0. यहाँ से हमें हमारे lambda i's मिलेंगे, these ones. So if you expand this, you will get something like this. Lambda minus 2. So your lambda 1 is 1. Your lambda 2 is also 1, and your lambda 3 is equal to 2. So this is the case of repeated eigenvalues. यहाँ पे जब देख रहे हो lambda equal to 1 repeat हो रहा है 2 times, और एक independent है lambda 3 equal to 2. तो repeat होने से क्या difficulty आ गई हमें? See, you have to evaluate beta naught, beta 1 and beta 2, so 3 unknowns. For that you need 3 independent equations. And equations कहाँ से आएंगी? Equations आएंगी from lambda i's. अब यहाँ पे कितने lambdas हैं? 3. अगर ये distinct होते हैं, let's say it were 1, 3 and 2, तो 3 different equations बनती in this polynomial, and you could evaluate beta naught, beta 1 and beta 2 separately. यहाँ पे ये difficulty है कि you are having a repeated pole or a repeated eigenvalue. तो इन दोनों से एक ही equation generate होगी. If you substitute the lambda equal to 1 here, beta naught plus beta 1 plus beta 2, isn't it? For lambda equal to 1. तो इससे एक इक्वेशन मिलेगी, इससे भी सिमिलर इक्वेशन मिलेगी, है ना? इससे एक डिस्टिंक्ट इक्वेशन मिलेगी, लैम्डा इक्वल टू 2 जब सब्स्टिट्यूट करेंगे विल गेट डिस्टिंक्ट इक्वेशन. तो यहाँ पे क्या प्रॉब्लम हुई? प्रॉब्लम ये हुई कि 3 आइगन वैल्यूज हमें 2 ही इंडिपेंडेंट इक्वेशंस मिल गई, बट वी नीड अननोन्स अब 3 है ना? तो वो कैसे इवैल्यूएट होगा? तो तीसरी इंडिपेंडेंट इक्वेशन कहाँ से आएगी वो हम देखेंगे. अच्छा ये ठीक है, ये मैं रब कर रहा हूँ. दिस इज डिटरमिनेंट ऑफ लैम्डा इक्वल टू 8. लैम्डास आपको यहाँ पे मेंशन है 1, 1 and 2. ओके, सो आपकी जो इक्वेशन थी f of a, सॉरी f of lambda, स्केलर पॉलिनोमियल, जो यहाँ पे लिखी हुई है, that's equal to e to the power lambda t, है ना? Because हमारा aim क्या है? To evaluate e to the power at, but in scalar domain it will be e to the power lambda t. We are replacing a by lambda. That is equal to beta naught plus beta 1 lambda plus beta 2 lambda square, and this all has to be evaluated at lambda equal to lambda I. Lambda equal to lambda I, where I lambdas are 1, 1 and 2. Okay. So if we put lambda equal to lambda first, that's equal to 1. तो क्या बनेगा? We will have e to the power t equal to beta naught plus beta 1 plus beta 2. फर्स्ट आइगन वैल्यू। तो यहां से तो एक इंफॉर्मेशन आ गई इन टर्म्स ऑफ बीटा 1 बीटा 2 एंड बीटा 3। अब हम एक काम करेंगे, ये जो इक्वेशन है जनरल इक्वेशन, वी विल फाइंड द डेरिवेटिव ऑफ दिस इक्वेशन। डेरिवेटिव से क्या होगा? डेरिवेटिव से विल गेट अनदर इंडिपेंडेंट इक्वेशन इन बीटा नॉट बीटा 1 एंड बीटा 2। So differentiating with respect to lambda, this equation, if I name it as A, differentiating A with respect to lambda, क्या होगा with respect to lambda? क्या आएगा लेफ्ट साइड? T e to the power lambda t, isn't it? Equal to constant term, you will get beta 1 plus 2 beta 2 lambda. यही आएगा। I'm just differentiating this equation with respect to lambda. So I will get this equation. Now put lambda equal to 1. The second lambda equal to lambda 2, which is also equal to 1. यहाँ पे हमने lambda equal to lambda 1 put किया, यहाँ पे lambda equal to lambda 2. But for our case, we are having repeated. So again, this is 1. Put lambda equal to lambda 1, which is 1 here. This will become t e to the power t equal to beta 1 plus 2 beta 2. This is the equation 2. ये समझ में आया? मैंने सेकंड इंडिपेंडेंट इक्वेशन कहां से लाई? समझ में आया?
यस सर।
हाँ, तो तीसरी इक्वेशन कहां से आई?
सर वो लैम्डा 2 से, लैम्डा 3 से।
दिस इज इंडिपेंडेंट आइगन वैल्यू, तो यहां से तो तीसरी इक्वेशन आएगी ना। Put lambda equal to lambda 3 equal to 2 in this. क्या मिलेगा? e to the power 2t beta naught plus 2 beta 1 plus 4 beta 2. This is your equation 3. Now you have 3 independent equations with 3 unknowns. तो ये सॉल्व होगा। बीटा नॉट बीटा 1 बीटा 2, this is in beta 1 beta 2 and this is also in beta naught beta 1 beta 2. So once you solve these 3 independent equations, you will get the solutions of these constant terms in terms of these exponentials, है ना? तो ये आप अगर स्टेप बाय स्टेप करोगे, I will just write a solution.
सर 2 को 3 में पुट करने के बाद वैल्यू मिल रहा है।
क्या करेंगे? क्या? हाँ
सर 2 को सर वैल्यू सर 3 में पुट करेंगे सर, उसमें 2 कॉमन ले लेंगे।
2 में है ना बीटा 1 एंड बीटा 2, यहाँ से बीटा 1 के लिए सॉल्व करो, तो इसको आप 3 में पुट कर सकते हो।
यस सर, वहाँ पे
देयर आर लॉट्स ऑफ टेक्निक्स जिनसे आप सॉल्व कर सकते हो, या 3 इक्वेशंस 3 अननोन्स। तो इसके 2-3 तरीके हैं। वन इज सब्स्टिट्यूशन, यहाँ से बीटा 1 ले लो, उसको इसमें सब्स्टिट्यूट कर लो, तो एक इक्वेशन में एक बीटा 1 आएगा, देन बैक सब्स्टिट्यूट you will get beta 2 and back substitute you will get beta 1. या क्रेमर्स सोलर, काफी मेथड्स है जिनसे आप 3 इक्वेशंस 3 अननोन में सॉल्व कर सकते हो। तो सॉल्विंग 1, 2 and 3, simultaneously we get, यहाँ पर लिख रहा हूँ कि what should be the value of beta naught. और to the power t plus 2 to the power t plus 2 to the power 20 and beta 2 beta 2 to the power 2t and c to the power t minus t to the power t. This is when you solve these three equations simultaneously. आप करो, it's not that difficult. बस substitutions करनी है repeatedly and you will get three constants for independent. So when you solve these three, आपकी जो इक्वेशन थी e to the power 18 है, this was beta naught I plus beta 1a plus beta 2a square. ये है ना in matrix form. This was f of a. Beta naught you have, beta 1 you have, beta 2 you have a also, और a square भी पता किया जा सकता है, isn't it? या इसको अगर मैट्रिक्स फॉर्म में लिखना पड़े -2 t e to the power t plus e to the power 2t -2 t e to the power t plus e to the power 2t 2t. This is your what? 0 0. ये आपका बीटा नॉट into I. Then you will be having beta 1 into a. है ना? ये आपका 3x3 मैट्रिक्स है. Beta 1 is this. अच्छा beta 1 into a कर पाओगे ना? A you have. A is what? मैं यहाँ पे लिख रहा हूँ फिर से. 0 0. Most of the terms are 0, तो इसमें कोई इशू नहीं है. -2, 0 and 3. So you have to do beta 1 into a. Beta 1 is this, so every entry will be multiplied by beta 1. तो यहाँ पे maximum term 0 है, just have 2, 3 and 1. वो multiply हो जाएगा, so it will be just like this. 0 0 -2 beta 1. 0 1 0 beta 1 0 3 beta 1. यहाँ पे congested हो जाएगा and you'll be having what? A square. First you have to do the square of a, then you have to multiply each entry by beta 2. मैं बस समझा रहा हूँ आपको कि स्टेप्स कैसे करोगे, है ना? तो एडिशन पॉसिबल है ना, तो यहां से क्या मिलेगा आपको? e to the power 80. ठीक है, I will write the answer. आपका e to the power 80 will come like this. It will get 3 cross 3 matrix. Isn't it in E? तो क्या है? 2 to the power t minus e to the power 2t. 0 0 e to the power t 0 2 e to the power t minus 2 to the power 2t minus e to the power t plus e to the power 2t 0. यहाँ पे 0 में वो टर्म तो 0 हो जाएगी. e to the power 2t minus e to the power 2. This will be e to the power 80. ठीक है, ये एंट्रीज जो है ये 0 हो जाएंगी और बाकी एंट्रीज में वो एडिशन प्रॉपर लैप को करना है. This was the first part of the question. You have to evaluate the function polynomial f of a which was equal to e to the power 80. तो आपने e to the power 80 के लिए ही सब कुछ किया है ना. इसके आपने दो मेथड्स अभी तक पढ़े, एक तो इनवर्स लाप्लास के थ्रू, another is if you have Caley-Hamilton. अच्छा, second part of the question was to evaluate x of t. X of t is what? E to the power 80 into x0 plus the terms. जो वो term है उसमें ut होता है, यहाँ पे ut given नहीं है, ut is 0. You just have this part of the solution. E to the power 80 आपने evaluate करनी है, you just have to multiply e to the power 0. तो again if you are अगर आप smartly चलोगे, जैसे मैंने लास्ट टाइम कहा था आपको, just see x0. x0 था given. इसमें एक एडवांटेज ले सकते हो ना आप. Only one entry is non-zero. तो जो भी आप e to the power 8 इवैल्यूएट करने वाले हो, this x not मल्टीप्लाई होने वाला है, and this corresponds to second column only. तो जो भी आपका e to the power 8 होगा, फर्स्ट कॉलम के साथ 0 मल्टीप्लाई होगा. This will corresponds to first column. This will multiply to the third column. तो सारी कैलकुलेशन जो आप कर रहे हो वो लास्ट में 0 के साथ मल्टीप्लाई होने वाली है. फ्रॉम एन एग्जामिनेशन पॉइंट ऑफ व्यू या अगर आप असाइनमेंट कर रहे हो, अगर आपको कहा जा रहा है जस्ट e to the power 80 इवैल्यूएट करो, देन यू हैव टू डू एवरीथिंग. अगर सॉल्यूशन पूछा जा रहा है तो आप ये एडवांटेज ले रहे हो कि x of 0 में 0 1 0 है, तो जस्ट आई एम कंसंट्रेटिंग ऑन द सेकंड कॉलम ऑफ e to the power 80. ये तभी पॉसिबल है व्हेन योर इनिशियल कंडीशन हैज 0 and 0 इन्वॉल्वड. हैड इट बीन सम नॉन जीरो तो आपको सारे कॉलम्स लेने पड़ेंगे. So only the second column is to be taken, and it's one. One का ये meaning हुआ कि जो second column है उसको as it is लेना है. अगर यहाँ पे कोई variable होता k, तो k से multiply करना था. The second column have to multiply with k. ठीक है? यहाँ पे simply one है. कहाँ गया आपका solution? Your xt is simply what? 0 e to power p and 0. ये समझ में आया सबको? Is this all right? Any question in this? Okay. So this was how do you evaluate e to the power 80 is a Caley-Hamilton theorem. इसमें आपने दो क्वेश्चंस देखे, वन और सेकंड ऑर्डर के डिस्टिंक्ट आइगन थे, एंड दिस क्वेश्चन वाज हैविंग थ्री डायमेंशनल सिस्टम. इसके दो पोल्स जो हैं वो रिपीटेड थे. सॉरी, वन पोल वाज रिपीटेड एंड अनदर वाज डिस्टिंक्ट. तो इसको हमने कैसे किया? जो डिस्टिंक्ट पोल्स हैं वो इंडिपेंडेंट इक्वेशंस देंगे. अब जो रिपीटेड पोल है उसके लिए हमने वी जस्ट फाउंड द डेरिवेटिव of the scalar polynomial and उसमें हमने substitute कर लिया, and you got three independent equations for three unknowns. और second part was to evaluate the solution. Solution के लिए आपने बस you have to multiply your e to the power 80 with your x0 and x0 is given, so you get the solution. इसमें अगर कोई forcing function भी दी होती, अगर आपके पास कोई u भी दिया होता, then you have the part of the solution जो u correspond करता है, इसमें वो add हो जाता. ठीक है?
Yes, sir.
Okay. So, any question, any doubt? अभी हमारे पास कुछ टाइम है. Any doubt? पूछ सकते हो अगर कोई डाउट है. Otherwise, we'll stop. Okay.
No,
Okay, then we'll stop. Okay then. We'll stop here. Thank you.
Thank you, sir.
Thank you.